Now we are going to start with the chemical properties of ether. So I just want you to know that ethers are actually very less reactive. They are actually very less reactive, you can say very limited reactions are there for ethers. But still we will look for a few reactions. As we know that ether is ROR. So we are going to look for the reaction of ethyl oxygen. We are going to cleave this bond RO, and even we are going to substitute this R, H of this R. Right. So the first reaction is reaction of ethyl oxygen. So as you all know that ether in like if you talk about ether, there are two lone pairs on the oxygen. So that means it acts as a Lewis base, and it can actually form a coordinate bond. Like with any ion which is actually acting as a Lewis acid. So the first one is reaction of ethyl oxygen with concentrated sulfuric acid. So suppose I have this ether and I have concentrated sulfuric acid. So what happened? We know that acid is actually formed of H positive and HSO4 negative ion. So what happened? It reacts in the way that it forms, like this lone pair is actually donated to this hydrogen ion, this thing, right, and it forms a compound like this, that is an intermediate. So this is a reaction in which you can see that ethyl oxygen with lone pair is just forming a coordinate bond with this H ion, and it forms a complex like this. Second is with air. So if you have an ether, I'll take an example here. Suppose I have this ether, I'm going to react with air. So what happened when it reacts with air? Actually, it actually forms the peroxide. It actually forms the peroxide. That is again a coordinate bond with 1O, right? And likewise, we can react with the Lewis acid. Suppose I have the ether, and I also have this thing, the electron deficient compound. Let's take BF3. So as we know that octet of this B is not completed here, so but it has a lone pair, so it can actually form a coordinate bond with it. So this is donated to this BF3. So this is how you are going to show the reactions for the ethyl oxygen. So there are reactions of the ethyl oxygen because it possesses the lone pair, so it can act as a Lewis base, and it can combine with Lewis acids, that means the compound which are actually in need of electrons, and form a coordinate bond. So as I have shown you three reactions, like with concentrated sulfuric acid, with oxygen it is forming peroxide, with BF3 also it is forming a compound. Second is cleavage of CO bond. Reactions involving cleavage of CO bond. Suppose I have ether ROR, I am going to react it with halogen acid. Let us take an halogen acid HI because it is highly reactive. So what happened? It cleaves in a way that like this and this bond is going to get cleaved. So as a result, we will get alcohol, and again we will get an alkyl halide. But if you will keep this hydro acids, halogen acid in excess, then you are not going to get alcohol actually. If you use this in excess, then what we get is we get only alkyl halide with water. So this is what is a reaction of halogen acid, and you have seen that there is a cleavage actually. C and O bond is actually cleaving. So this is how the cleavage occurs. Similarly, we can show the cleavage with PCl5. Suppose I have ether and I have PCl5, then what I am going to get? I am going to get again alkyl halide, that is the alkyl chloride actually, and along with that we will get POCl3. So this is again a cleavage, right? Third, with acid chloride, suppose I have an ether, we react with acid chloride. Let's say we know that acid chlorides are particularly ROCl. So it is again going to cleave this way, and what we will get? We will get again RCl, and along with that we are going to get a pleasant smell, pleasant odor substance, that is the ester. So that means if you cleave it, you may get an alcohol and alkyl halide. You may get only alkyl halide if halogen acid is present in excess. With PCl5 you get the again alkyl halide. With the ROCl, that is acid chloride, you get the ester as well as the alkyl halide. So this is what is involving the cleavage, right? The third property is the reaction of alkyl group. So reaction of alkyl group, as you know that, suppose I will take an example of ether. Suppose this is my ether. I am going to carry out the halogenation. Let us say that we are going to carry out the chlorination, and it is occurring in dark. So we know that like if I write an open structure, it is particularly like this. it is particularly like this. So these are the alpha carbons which possess the hydrogen. So here halogen is going to replace this hydrogen one by one. So what we can get actually, we may get this 1H will be replaced by Cl, and likewise you will get chlorine substituted compounds. And if I use this in excess, then these all H may replaced by chlorine. For example, if I use the Cl2 in excess, approximately 10 Cl is used. So what you see is, you see that everything get converted, like all H get replaced by Cl, and we get CCl3, CCl2, O, CCl2, CCl3. So that means everything is just replaced by the Cl. So these are what the chemical properties of the ether. The one involving the ethereal oxygen, where you have seen that you get the coordinate bond formation. With CO cleavage, you see that you get different compounds, like with halogen acid you got alkyl halide and alcohol, and if it is in excess you may get only alkyl halide, and here halogen acid which you prefer is HI or HBr because they are only reactive. And the next is PCl5, you get RCl with POCl3. With acid chloride also you will get alkyl halide with ester, and with the reaction of alkyl group involves the halogenation, which I have shown you the chlorination, in which hydrogen is actually replaced by the halogen, and it occurs step by step, but if you use this in excess, so all hydrogen may get replaced by the Cl. So these are all about the chemical properties of the ether.